Hello everybody, Chris here, and in this video I'm going to be showing you guys how to set up Grid Builder Plugin version 4 for your 2D Godot 4 games. So this will include setting up the systems with the new resource objects that are required, creating a placeable and setting it in the placeable selection UI, and at least adding one building rule requiring a collision check to verify that there's nothing in the way before you can place an object into your game scene. So in the project, I need to install the Grid Builder plugin. So I want to right click on the resources in the file system in the bottom right and do create new folder and make it add-ons. It should be written exactly like this, all lowercase, and that's where you stick all of your add-ons in Godot. Okay, now we want to right click the add-ons folder and open this up in File Manager. In a different folder, I'll go to where I have the Grid Builder plugin downloaded as a zip archive. I'm going to open it up. And then I'm going to bring in grid building into the project. So the first time you load in the project, you might get these messages about using the text path instead of the unique identifier for certain resources, mostly PNGs. This should only happen the first time, and you don't need to worry about it. So you can clear those messages, and then we need to go to project settings, over to plugins, and enable grid building. And now we can start setting up our systems inside of our game scene. So what I've liked to do is keep my systems completely separate from the world itself. The world and the levels may come and go, but the systems are always running in the background. So if we right click on game and we add a child node, we can just do a simple node here. And I'm going to add it and rename it to be systems. So now anything that's a system, I'm going to put up here. So I'll bring world below systems in the hierarchy. And now anything that's a system will just be nested under this category. So I'll right click and add a child node. The first system we need is building system. So we want building system.gd, create that. And then I'll right click here and add a child node. So we want to have grid targeting system. So these are the two main systems for the plugin. The building system creates preview instances and places objects onto the scene. And then the grid targeting system snaps your cursor movement to where you will be placing your objects. So for the grid targeting system to actually move the cursor around the screen, we need to have a grid positioner node 2D, which the grid targeting system will process everything on. So let's go to the files and search for positioner. So positioner.tscn, we can just drop this. I've been typically doing it under the world node. As long as it exists in the scene and you give it a proper reference to the building state, which we'll do in a second, it should be able to be referenced by the grid targeting system. So about the building state, typically I will go to building system to create that. Technically, you can do it on any node that requires a reference. So if we click here and do new building state, we want to right click this and save it to our project. So I'll create another folder here for state resources. So I could call it state or states. I might do states. And then we'll call this building_state.tres because it's a resource file. So if we expand building state, you'll see that there's only one visible or exported property here for the building mode. So when the mode is changed to build, which will be done by a hotkey later, then we get into building mode, and that's where you start seeing the preview instance and being able to place objects into the scene. Also, when the grid targeting system will show the grid positioner. Move and demolish haven't been implemented yet, but that is my goal for the next patch, to be able to move and demolish already existing objects in your scene. Okay, so we have this building state TRES. We want to reference that in the targeting system. So if we go to targeting system, we click the drop down quick load, we should be able to find states building state.tres. But if for some reason it can't be found in the quick load, you can just search your project for state and drag and drop building state into that box right there. And that's all you need to do to share this building state between the building system, the grid targeting system, and any other objects. So grid positioner will drag the building state here as well. So hopefully you can see how with resources, it's very easy to share data between objects. They don't even have to exist in the same scene because you're referencing an object in your file system, not in the scene itself. Okay, so then we need a grid targeting settings. So I'll create that here, new grid targeting settings. I'll right click save this into, let's say, root project and then a settings folder. So I'll call this grid targeting settings.tres since we're only going to need one for the project. And of course, that needs to go in the grid targeting system. So I'll quick load that same grid targeting settings. And then we need a few more resources in the building system. So the building settings, we'll do a new building settings here. We'll right click, save that, building settings.tres, just so it can be referenced elsewhere. The placement validator, we do need a new one of that. Currently, the building system is the only place that actually needs the placement validator. If you want to save it to the project, though, in case you ever lose your building system, that these settings are still saved, then you can do that as well. So we could do save as, and maybe for now we put it in settings as well. So placement validator.tres. So this does do more than just have settings here, because this is what validates the building rules against the TileMap grid to ensure that placing an object into the scene is valid. So we'll set up a base rule later, and that's really the only thing we need to worry about in this tutorial. So we'll close that for now, and input actions is another setting, so let's create a new one of that. You can see all of these default names for actions within the building system. So you'll see rotate right, rotate left, flip horizontally, and flip vertically. If you want to be able to rotate and flip your objects, then you should create an action with this name or any name you set inside of project settings, input map. If you prefer not to rotate your objects because it doesn't make sense for your style of game, then you could just go to building systems and you can turn enable rotate, enable flip horizontal, and enable flip vertical off. Also, if you want to be able to press and hold to build multiple objects just by dragging your mouse cursor around the scene, then you can enable drag multi-build. It's also recommended for the build action, which is defaulted to UI accept, that you change that to a custom action so it doesn't interfere with any of the default UI actions. So we can give this another name like build. UI accept, by the way, would be enter key by default if you want to test with that first. But we can go ahead here and create a bunch of actions for our system if we choose. So let's add build, rotate right, rotate left, flip horizontal, flip vertical. And you can assign these to whatever key bindings you want. So for build, I'll make the key left mouse by clicking right here. Okay. For rotate right, we can say perhaps R on the keyboard. For rotate left, I'll make it E. For flip horizontal, maybe F, and then G for flip vertical. You can, of course, set those to whatever you want. Exit build mode action, the default UI cancel. We can still use that. It would be escape key on the keyboard, which will turn the build mode to off. One more setting we're going to need for building system building settings is going to be to choose a rule check indicator template. So if we search rule check in the project, there's a few options here for out-of-the-box defaults, including rule check indicator 16 by 16. Now, the TileMap grid here is 32 by 32, so we might want to scale this up for our game. And it may even be a good idea to duplicate this to our project, especially if we're going to edit it. So I'm going to right-click, move, and copy it to, let's say, objects, and then building. So hit OK there, and copy it into there. So for this, I'll say rule check indicator tutorial. Okay, and we'll assign this to the rule check indicator template. So now we can double click this if we need to edit it. But to take our rule check indicator and scale it up to the tile size of the grid, we're going to want to take rule check indicator tutorial, click on the root rule check indicator 16 by 16, and I'll just rename that actually to be tutorial. And then go to the inspector where it has shape. And we're going to put this as 31.9 and 31.9 pixels, just shy of the 32 by 32 tile size. And then for our validity sprites, we could either replace this with a bigger sprite, or you can just keep it simple and go to transform, and I'll just scale it up to X. So now with that, we also want to go to the game view, and I'm going to right click and edit the children of the positioner. And this grid targeter, we also want to double the size because it's set up for 16 by 16 by default. So I have some example UIs created in the Grid Builder plugins. So to add those in, I can right click on the game root node and let's add in a canvas layer. A canvas layer separates all the UI completely from the other 2D world scene. So stuff like lighting will never affect the canvas layer if it's not within that canvas layer. So generally I use this as the root of my UIs at the moment. And then inside of here, I can look for the placement selection UI. So if you just search place, we can just drag that in there. You'll notice that in this version, the building state is referenced here instead of the building system. So we need to find the building state here. So I'll search state and just drag and drop building state into there. There are settings associated with this, and I have not made this into a resource file yet, so they're just embedded in the node. So you'll see we need an open action in order for the UI to work. So if we go to project settings, and we do import map, I will add in open build. Of course, you can rename this action to whatever you want it to be, but I will make it B on the keyboard. So B opens the menu, and build mode will start when we select a placeable. So if I zoom out a little bit, we can look at this purple border. So this is the frame of our actual game window. And we can see that the placeable selection UI is going to default over here to the right. So in order for this list to populate, it's going to have tabs at the top based on category tags. And placeables are going to fill into those lists based on what tags the placeables have. So we need to create some categorical tags for our game and then assign those in the placeable resources. So let's create a category tag. I'll just expand this array and create a new one. So this will be, let's say, plants. And for the icon, you can use whatever graphic you want. I might just select a atlas texture, look for the art of the project. So in assets art, I have in Kanos's pixel art top-down basic pack. We can grab, we can grab a plant here and assign it inside of the atlas texture. So I'll grab txplant.png and let's select a icon we want to use here. So I might just grab this. Okay, close that. Okay, and there's our little icon. So we want to save this categorical tag so we can reuse the resource across our placeables. So I'll right click, save as, and we can go into, let's say, objects and create a folder for tags. So tags, and I will call this tag plant. Save. Okay, now where you put the placeable resource is kind of up to you. You could create a separate folder for the placeables, or if you want to combine it in the same directory as your actual scene that the placeable is going to be instantiating, then you could just create a folder for each object. So that's really a design choice on your part. For this tutorial, I'll go ahead and create a folder for tree, and I'll move tree.tscn inside of there. So now in this tree folder, I want to right click, create a new resource, search for placeable, enter, and we'll do, let's say, placeable underscore tree.tres. So initially we'll get a bunch of intentional warning messages here that says that the packed scene must be set for the placeable to be instanced. So packed scene over on each placeable is right up here. You want to assign the scene you're trying to instantiate into the packed scene. So the tree here would be one of these trees. So I could actually jump into it by double clicking here or accessing it through the hierarchy. And we can see you can create any 2D object and create it from the packed scene for your placeable. Okay, so now we want to edit the rest of the placeable settings. So let's give it a display name for the placeable in game, tree. For the icon, I could just assign the tree graphic if I so choose. So if I go into the tree scene, I can just copy paste this texture and we can click on the placeable and just right click, paste it in there just to keep it simple. For tags, you'll see here that this takes an array of resources. So I intentionally made it a bit more flexible than requiring you to assign solely categorical tags, but you can technically tag it with any resource, but we're going to be assigning just a tag. So I'm going to search for tag and drag plant into this slot. Okay, now this object is being tagged as a plant. So for placement rules, if you decide that you have object-specific placement rules, such as the amount of resources that it spends to create one of these instances, then you can assign it in here for each placeable. For a rule that applies to all objects, usually collision checks, you would assign that on the placement validator instead. And then if you want your object to be rotatable or flippable, you can put this in here. I think for a tree, it makes sense to be able to flip it horizontally, but flipping it vertically makes no sense, and rotating it around the scene also makes no sense. So that'll basically be our setup here. Oh, and keep script paths. On the preview instance, if you have any scripts attached to your nodes here that you want to actually execute while it's in a preview instance before placement, then you can put a node path here to keep that script. Otherwise, all the scripts are removed to keep the scene as simple as possible and to not execute as if it was actually officially in the game yet, so to speak. So we have our placeable. Let's go back to the game view. Our placeable selection UI needs a placeable, so we will add to the menu, and I will search in the project placeable. So let's look for our placeable tree here and drag it into that. And now it should pop up in the menu. So if we want, we can also have the menu show at start, but we're going to be opening it through the B key, the open action, open build. Once again, that's an input action, open build here. And you may choose to hide the UI once an object is selected from the menu and placeable mode, and then build mode starts. That's up to you. I'll leave it open for right now. So let's run the scene. I'll hit B to open up my build menu. I'll select the tree. You can see that the size of the icon is based on whatever you put into it. So if you want to use a smaller, consistent icon size, then you should create an icon version for each object in the game. Otherwise, it'll just use I believe, the full initial sprite size. Over here, these are bigger because the camera is on 2x scale, but this is the original sprite size. So if we click on the tree a few times, we'll get some warning messages in the console. So you'll see that the tile map, the place parent, and the placer have not been set. The positioner has, because the positioner automatically sets itself if you're using the grid positioner script here. But these other objects we need to set for each level we load into the game. So there's a script I've added to Grid Builder to easily have that set up whenever you load a new level. So if we open an editor, our test level, we can right-click, add a child node, and we want to look for building state level setter. So I'm going to add this here. This takes the building state. So let's search for building state, put that in here. And then whichever node references we set here are going to be added to the building state whenever this level loads. So in my demo project, I actually have the world and the level handle that themselves. But in your project, you might not have a level script already set up. So this is just something that you can use as an easy way to get the build system to work, and you don't have to worry about having to code any of that level-based stuff yourself. And even if you do code a level script, you could just keep this totally separate if you want. So your placer should be your character inside of the level. You can see that in this case, there actually is no player in the level. And in fact, the camera out here is kind of going to serve as the player for this demo. So we'll leave that blank for now. But the place parent, I want objects to go in this objects area. So I'll assign objects. And the tile map is up here. So in Godot 4.3, they're actually adding TileMap layers. The original TileMap is going to be deprecated. So right now, layers are embedded in the TileMap, but in 4.3, they're going to be pulled out to their own individual layers. 4.3 isn't out yet, so I will be adding the support for TileMap layers instead of TileMap node in the future. That's something to keep in mind. TileMap is going to be deprecated eventually, and in favor of that, TileMap layers is going to be the new way of doing things. So for the positioner, no need to set it because, once again, the grid positioner is automatically setting itself in the building state. And what I can do, because the character isn't in this level, but it is in the world, the camera 2D is going to serve as the character in this case, is I can add another one of those scripts right into the world node. So building state level setter. And when this loads, we will set the placer to be the camera. So that might not initially make sense to you. And really any node can serve as the placer. But in cases like you're using spend materials rule generic, it's going to look at the placer node to see if there is a item inventory that would hold resources for building objects into games. We're not going to add that into this tutorial, but just note that the placer is that object that we're looking for things concerning the player. So if you have an item inventory, that's kind of what you're going to want as the root node, the player node or wherever the item inventory is attached to. So this is going to need the building state as well. Okay, and that should be good. So we have one of these setters in the world and then one in the level itself. Okay, so let's go ahead and run our game scene. I'll hit B, we select our tree, and we can place it wherever we want around the scene. So if I hit R for rotate or E for rotate, you'll notice that it doesn't do anything, but I can hit F to flip it horizontally. G doesn't work, but F does because we enabled it on the placeable. So let's find where we want to place it, and I'll left click, and we place an instance into the scene. So if we go up here as well, we can place it on the roof or even inside of the walls. Now, why is that? It would make a lot of sense if there was a collision check rule here to prevent us from doing that. So we'll close the scene, and I'll go into the building system, and let's add in a simple collision check rule. So we'll do that on the placement validator. And then inside of here, we'll create a new collision check rule. You'll see that there's a few defaults here. You can also create your own rules by inheriting from building rule or tile check rule. So we want a collisions check rule. So in this case, we do not want it to pass on collision. We want it to fail on collision. The collision mask layer, we're going to check against layer 1, and we're going to apply this to any objects in the preview scene that are on layer 1 for now. So let's run the scene. I'm going to select the tree, and if we move it over the tree area, remember those have a collider, then you'll see that it's red, and if I left click, it won't place the tree into the scene. Anywhere else works, and currently even the walls here work because I have not set up collisions on the tile map. So if you're wondering on how to do that, let's go into the test level, the tile map, and we want to select the tile set up here. And what we'll do on the tile set tab at the bottom, for any object that we want to assign a collision shape to, let's look for TX tile set wall in my case, and any of these tiles where we want a collision to occur, let's make one happen. So we want to go to paint, click on the tile we want to edit, select a property, and our property is a physics layer, but none's been created on the tile set yet. So in tile set, we need to add a physics layer. So let's add that. Collision layer 1, collision mask 1 will work just fine for right now. And then we want to paint on this tile. We select from the dropdown physics layer 0. And by default, it will just put a full box around the tile, which will work just fine for this one. So you left click, and now it has a physics layer. So you can just do that to all of the tiles that you want to have this collision shape. Now, for other tiles, like these ones right here, you can see that there is a bunch of transparent space. You probably don't want that transparent space to actually cause a collision. So what you can do is left click on the tile, go over to this little editor, and pull these points to the left. But I'm also going to enable grid snap. So let's do grid snap. 4 pixels looks okay. So I'll pull these points to the left. And now I left click on the tile again. And now the collision is only over here on the left. So there's hotkeys for flipping over here as well. So if we do H to flip horizontally, we can click over here and assign that to up there. R to rotate to the right a few times, then we can click up there and add that in. So it can be pretty easy to actually assign the same physics shape to other tiles that need it if they have a similar graphic. Now for these corners, we'll need to click here. So I'll edit points. Let's see, if I click there, then we add a point and bring that down there. I'll put one in the middle and make that the middle section. So basically, if you just click on the edges, you add a point and you just drag it to where you need it to go. And then you click over here and boom, collision shape. So now if we are to rotate this, we can get there and assign it to anywhere else that it needs it. So in the tile map, I kept basically all of what I drew to these shapes over here, I believe. So I don't really need to edit the full tile set. Let's go back into game mode. So actually, if I go to debug visible collision shapes and we hit game mode, we should be able to see them in game. So we can see where our collision shapes are. So it wasn't all the tiles actually, but if I take the tree and I move it over to where there is a collision and left click, then you'll of course see that that's not going to allow me to place, but I can place down here where there's no collision issue on what's going on. So there's another UI you can add in the file system. If we look for the build log, so build log.tsc, and then we could just drop this into canvas layer. And this is going to take a building state. And basically whenever the building state emits signals, it's going to list the messages inside of this log. So let's quick load the building state, and you can search the project for the BuildingState.trs if it doesn't show up there. Sometimes they just don't show up in the quick load, not sure why. And if you want extra information rather than just reasons why building failed, then you can check validation messages, success reasons, and you could also print on drag build, but print on drag build might be too much information if you are building 20 trees in 1 second by dragging across the screen. So the build logs in the bottom left, by default, it doesn't have any background, but if we right click and do editable children, then we could simply add a texture for the background here on the 9 patch rect. So I might do something like a new gradient texture. And then with this texture added in, I could go to visibility and let's self-modulate and lower it down a bunch. Okay, and there's our super basic background. So let's run the scene. Okay, we have the build log there. Let's try placing some trees in. So I'll place a tree. Okay, we have all of the information posting. So everything passed, no collisions were found, and because it's blue text, that means it was successful, the tree gets built, and so on and so forth. If I try to place where it's obviously red on the indicator, then we'll get rules failed, must have no collisions, no build message. So that's probably too much information, so you can just turn off show validation message, which would be that top line above the success reasons. If you want, you can keep the success reasons on, or you can just turn that off as well. So now it will look more like this as the default. We get a fail message for no collisions. And if it succeeds, it just prints successfully. And we can place our objects around the scene. So one new feature I want to show off for Grid Builder 4 is that when you actually place an object into the scene, by default, it's going to add a placeable instance node to the hierarchy of the placed scene. So if I look at my remote view, which is what's currently happening in game, I expand everything, go into the world, test level objects, and we have the tree 5. I expand that again, and you'll see this placeable instance. Now that doesn't exist on the other nodes that exist in the scene in the editor, because those weren't placed into the game. Placeable instance here is going to contain a reference to the placeable resource that it was created from. So when you're actually saving the data of anything you place into the scene, and you want that to respawn into the scene later, node will be helpful for you. So basically, it has a few methods. So if I was to look at the class, you can see that it can save the reference to its position, the name of the root object, and the placeable to a dictionary. And you can save that to a JSON file. Likewise, it can instantiate from that saved dictionary. So whatever you save with this, you can load with this and create a new instance of the placeable object back into the game whenever your levels load. So to see a full example of that working, you should check the demo project because that has a actually working save load system. This would only be a small part of it. But I can show you an example of what this looks like if you convert it to a JSON save file. So in the demo projects, all 3 demos, I have a world state, which holds level states. And in each of those levels, which are saved by a file path reference to the scene it was created from, we have the placed objects into the scene, so anything instantiated with the Grid Builder plugin. And then here is that data that we're getting from the placeable instance, the name of the object, the file path to the resource it was created from, and the transform of the object inside of the game scene. Now that's all you would need to re-instance a new copy of the object back into the game. If you have specific script variables, then you would need to add those to the saved dictionary as well. Like, for instance, if you were using my world time plugin and there was an aging component attached to the object and you want to remember the age, then you would need to serialize that age as well when saving everything to JSON. But this placeable instance will grab you, at the very least, this bare minimum to re-instance the object. And from there, just grab your other scripts and serialize the data similarly. So that's what this bit does. And these are added automatically for any object you create through the Grid Builder system. If you want to turn that off because you have your own way of doing things, of course, you can go to Grid Building System, and in Settings, you can just turn off Add Placeable Instance, and that won't be there anymore. And you can figure out your own way of keeping your objects persistent between saving and loading the scenes, or just switching levels inside of your hierarchy. So that's pretty much going to cover it for this version of Grid Builder. The general focus I was going for with this update was that I wanted to pull everything out to resources so that it was easier to reference things like the building state between objects inside of your game. So when you have a resource that's saved to your project, different scenes can reference the resource without being in the same hierarchy when the game loads. So for instance, maybe your test level needs to reference the building state, but your level might not actually exist in this main scene. Maybe you have a bunch of levels and you don't want them all to be loaded at the start of your game. So that's when you use a reference to a building state, and they don't have to be in the same scene, at least initially. So resources are really helpful in that way. And that's why I'm using them a lot more lately across all of my work and plugins and tutorials as well. So going forward, I want to add in the ability to move placed objects using the build system and the grid targeting system, and to also demolish them and optionally get some of the resources back if they were spent to create an object. So keep an eye out for those updates, but for now that's going to be it. So thanks for watching my setup guide for Grid Builder 4. I've been Chris, and I will see you guys in my future video content.